Hello everyone, it's lecture 8 of Algebra by iTunes Academy. Relation between equation, coefficient, and its roots. Okay, so if we have this polynomial equation f of x equal to a node x power n plus a1 x power n plus 1 plus a2 x power n minus 2 plus here we have plus a n. Okay, there are some relations between here a node a1 a2 a3 to an and the roots x1 x2 x3 to xn. Okay, so here the first relation is if we have summation of xi and here I from 1 to n, this equal to x1 plus x2 plus x3 then plus xn, this equal to negative a1 by a node. Okay, and here the second summation of here we have xi xj, here I j from 1 to n. Okay, this equal to x1 x2 plus x1 x3 and this equal to a2 by a node. Okay, the third summation of here we have xi xj xk, here I j k from 1 to n, this equal to x1 x2 x3 plus x1 x3 x4, this plus okay, this equal to negative a3 by a node. Okay, the fourth is x1 into x2 into x3 into xn equal to negative 1 power of n, and here we have n2 an by a node. Okay, let's just move this to here and start with our the polynomial equation cubic x minus 2x plus 1 equal to 0 has roots of x1 x2 and x3. Okay, then prove that 1 x1 square plus x2 square plus x3 square equal to 4 x cubic 1 cubic x1 plus cubic x 2 plus cubic x3 equal to negative 3, and here x1 power 4 plus x2 power 4 plus x3 power 4 equal to 8. Okay, so to prove, here we have a node equal to 1, here a1 equal to 0, a2 equal to negative 2, and here we have a3 equal to 1. Okay, then x1 plus x2 plus x3 will be equal to, here we have negative a1 by a naught equal to 0 by 1 equal to 0. Here x1 x2 plus x1 x3 plus x2 x3 equal to a2 by a naught, that's equal to negative 2 by 1 equal to negative 2. Again, here we have x1, x2, x3 will be equal to negative a3 by a naught, that's equal to negative 1. Okay, so let's start with the first one. We have to prove that here x1 squared plus x2 square plus x3 square equal to 4. Okay, this expression from, as we know, if we have x1 plus x2 plus x3, this square, this equal to x1 square plus x2 square plus x3 square minus 2 into x1 x2 plus x1 x3 plus x2 x3. Okay, so here this equal to x1 square plus x2 square plus x3 square equal to, here we have x1 plus x2 plus x3, this is positive square minus 2 into x1 x2 plus x1 x3 plus x2 x3. So we have here from this relation x1 plus x2 plus x3 equal to 0, and here we have minus 2 into x1 x2 plus x1 x3 plus x2 x3 equal to negative 2. So we have here negative 2 into negative 2 equal to 4. The first one is proved. Okay, let's move to second one. Okay, so here we have to prove that cubic x1 plus cubic x2 plus cubic x3 equal to negative 3. Okay, so just we notice that from this equation we have here x power 3. So if x1, x2, x3 are roots of f of x, then f of x1 equal to f of x2 equal to f of x3 equal to 0. So just we can substitute with x1, x2, x3 into this equation. So here we have cubic x1 minus 2 x1 plus 1 equal to 0. Here we have x cubic x2 minus 2x2 plus 1 equal to 0. Here x3 cubic x3 minus 2x3 plus 1 equal to 0. Okay, thus we get the summation of these three equations. So we have here x1 cubic x1 plus cubic x2 plus cubic x3. Here we have minus 2 into x1 plus x2 plus x3 here plus 3 equal to 0. Okay, this x1 plus x2 plus x3 equal to 0 from the first one here. Okay, then this will be equal to negative 3. So we have here cubic x1 plus cubic x2 plus cubic x3 equal to negative 3. The second one is proved. Okay, let's move to last one. We have to prove that here we have to prove that x1 power 4 plus x2 power 4 plus x3 power 4 equal to 8. Okay, so as same as the last one, we can substitute in this equation. Okay, and just multiply our f of x into x. Okay, so let's do that. If we make that and substitute with x1, x2, x3, we obtain that x1 power 4 here minus 2x1 squared plus x equal to 0 here x2 power 4 minus 2x squared plus x2 equal to 0 x3 power 4 minus 2 x3 squared plus x3 equal to 0. Then we get the summation of the three equations. So here we have here x1 power 4 plus x2 power 4 plus x3 power 4 here minus 2 x1 squared plus x2 squared plus x3 squared plus x1 plus x2 plus x3, okay, equal to 0. So we have here x1 x power 4, and here from the first one we brought, we have here 4 from the first one here, okay, and this equal to 0 from here, okay. Then x1 power 4 plus x2 power 4 plus x3 power 4 equal to 2 into 4 equal to 8. The third one is proved. Let's remove that and move to that equation. Cubic x minus 9x squared minus 23x minus 15 equal to 0 if these roots form an arithmetic sequence. Okay, so the arithmetic sequence here, we can write that our roots are a minus b, a, and a plus b. These numbers form an arithmetic sequence. Okay, so before we start, we have here a node equal to 1, a1 equal to negative 9, a2 equal to negative 23, a3 equal to negative 50. Okay, so here we have x1 plus x2 plus x3 is equal to negative a1 by a node is equal to 9, and here x1 x2 plus x1 x3 plus x2 x3 equal to a2 by a node is equal to negative 23 plus 1 x1 x2 x3. Okay, that's equal to here negative a3 by a node. So we have here 15. Okay, so let's start based on these three relations and apply this to our roots here. So the first one we have here a minus b plus a plus a plus b is equal to 9. Then 3a equal to 9, a here equal to 3. Okay, from the next one we have here a minus b into a plus a minus b into a plus b plus a into a plus b. Okay, this from the second one equal to negative 20. Okay, so we have here a square ab. From here we have plus a square minus b square, and we have here plus a square plus ab equal to negative 23, this with this, and we have here 3a square minus b square equal to negative 23. Then b square equal to 4, b equal to plus or minus 2. Okay, so we have here a equal to 3 and b equal to plus or minus 2. Okay, so just remove this and obtain our roots. So here f p equal to plus 2 and a equal to 3, then our roots are a minus b equal to 1, a equal to 3, and here a plus b equal to 5, okay? And here f b equal to negative 2, a equal to 3, our roots here a minus b equal to 5, a 3, and here a plus b equal to 1, okay? Here, and we have find the roots of that equation. Here we have cubic x minus 13x squared plus 39x minus 27 equal to 0. If this root form an, but here these roots for a geometric sequence, okay? So here we have if these roots form a geometric sequence, then these roots can be written as this. Here a by r, he air, and he a into r. Okay. Here we have a node equal to 1, a1 equal to negative 13, a2 equal to 39, a3 equal to negative 27. Okay. So here just write our relation x1 plus x2 plus x3 will be equal to negative a1 by a naught. This equal to 30. Okay. The second x1 x2 plus x1 x3 plus x2 x3 equal to a2 by a naught equal to 39. Okay. The third one is x1 x2 x3 will be equal to negative a3 by a naught. This equal to 27. Okay, just apply this to our roots. So we have here from the first one a by r plus a plus ar equal to 13. So here we have a into 1 by r plus 1 plus r equal to 30. Okay, here if we apply the second one also, we will obtain a relation between a and r. So because we have here geometric sequence, we just apply the last one to get rid of r. Okay, so we have here a by r into a into ar equal to 27. So from here cubic a equal to 27. So a here equal to 3. Okay, just substitute with a into 1. Okay, so we have here 3, 1 by r plus 1 plus r equal to 13. Okay, just we have to multiply by r. So we have here 3 plus, here we have 3r plus 3r squared equal to 13r. Okay, so here r 3r squared, okay, minus 10r plus 3 equal to 0. Then r here, right, this will be into 3r minus 1 into r minus 3. So r here equal to 3 or 1/3. Then if we substitute here by a equal to 3 and r equal to 3 or 1/3, then our roots are 1, 3, 9. Okay, this is the roots of this function. I hope the relation between equation coefficient and its roots clear. Okay, just we follow this relation to get any of polynomial roots. Okay, but it comes difficult when the power of the leading term of polynomial is larger than 4. Okay, I hope all is well with you from the first lecture of algebra, and thank you.